Hello. Tell me if the voice is clear to everyone so that we can.
If the voice is clear to everyone.
Okay. I hope that it is clear.
So that we can. The voice is clear to everyone.
Okay.
I hope that it is. I hope that it is.
Just wait a minute. Nice. Namaskar, Adab, Sastyakal. How are you, students? I hope that all of you are doing good. Okay, your exams are also very close, so I hope that you are studying very hard for your exams. Okay, it's a exam season that is going on for your boards exam, NEET exam, CET is also very soon coming. Your second attempt JEE is also coming. So JEE Advanced, if some students are preparing for JEE Advanced, all the exam season is here, and I hope that you are not deviating from anything and you are just focusing on your studies. Once you crack this exam, then you have complete 4 years to do such, or just explore your life completely. I will tell you, because I'm an engineer, so I will tell you the engineering background. Rarely anyone study. Of course, everyone studies, but you have to study for good placements and your higher studies. But major part, like the hard work that you are putting in right now, you are not going to do that. You are going to completely explore your life, either in singing, dancing, swimming, sports. A lot of sports activities goes on in engineering college. I will only talk for engineering college because I know better about that. So just put in hard work and you will get a lot of good exposure from your this much of hard work for the complete rest of your life, I will say. See, if you are not, everyone cannot clear this exam, I will always say. But if you are on the colleges like tier 1 colleges, IITs and NITs, you will have the opportunities firstly. Okay, you will have a very good exposure. The life at IITs and NITs is uncomparable. Okay, in tier 3 college also students succeed. It's not like that no one can succeed by going in, but you have to put 2x of the hard work then for the rest of the 4 years. If you have enjoyed now, you have to put the hard work. See, without hard work, there is no shortcut for the success. So you have to put extra effort there, and the other students will be just enjoying and exploring their life, and they will get the opportunities first also. You will also get, but after having them, if they will be left with some opportunity, then that opportunity will be coming to you. I have seen a lot of good coders from the tier 3 cities cracking the biggest exams. Okay, because they know they don't have any option. No opportunities are coming on their way. They have to go and crack the opportunity. Okay, so this is a basic difference. So I will say it's very critical time. It is not career deciding. I will never say career deciding, but it will give the direction for your career. How your career is going to be, it will for sure it is going to give the direction for your career. Okay, so I hope that you are honestly putting your complete hard work, whatever you can do. Just remember the goal, the happiness that you will be having after achieving this exam, and this will motivate you. Always have self motivation. Either I am motivating, either someone else is motivating. That is external motivation that will goes down in 1 or 2 days. But if you have that internal fire, internal motivation, then you can crack this exam, and that is very required for this exam. It should be complete madness. You are sitting for 13-14 hours without any break, or you should be mad completely. Then you will be at the level of this competitive exam. Okay, I hope that is clear. Now, if I'm talking about the last portion that have been completed, we have completed wave optics. Ray optics. Now we are in the second portion of optics, that is wave optics. So I will give you a brief introduction before starting this. Actually, I have to tell you after this chapter, but still I will tell you a little bit. Okay, there was a if I will tell you, tell me what is light behavior, wave nature or particle nature. Anyways, we have not started. We are still in wave optics is completely study about waves. So we are assuming that light is a wave nature. But if anyone knows from the basic classes also that light is actually dual nature, both particle nature and wave nature. My voice is clear now? If anyone knows from the basic classes also. Voice is clear. So from where this all debate started in the 1765, if I am not wrong, please correct me if I am wrong. The dates I am very bad at remembering. First theory was given by Newton about light. No, Newton sir was everywhere. Okay, he had explained everything. Okay, so he have explained that light is actually a particle nature. he have given his own theory of corpusculars, that light are in the form of small particles, that is called corpuscle. So he have given his theory of corpuscular theory. Okay, so of course no one was at that caliber that who will reject his theory, so it was accepted that okay, light is of particle nature. Okay, but after very soon, nearly one more scientist, that is our today's topic, Christian Huygens. Okay, he was the scientist who explained that he have given the concepts of wave fronts and how waves are propagating, and he have proposed that actually light is not particle nature, but light is what? Wave nature. He have performed some experiments, I will tell you, but no one has accepted it. Okay, no one has accepted it because he was unable to. Newton was Newton. Okay, by level. Okay, न्यूटन सर का तो लेवल था, तो उनको गलत प्रूव करना इज द टफेस्ट थिंग. ओके, so what happened after 1 year, in 19th century, after 100 years, okay, nearly I am talking, I'm not going into exact dates, one more scientist came who was Young's. Okay, and that is the second topic of this chapter, about Young's double slit experiment. He have performed an experiment and he have concluded that actually Huygens was correct. Actually Huygens was correct because he have performed a double slit experiment. I will tell you, that is a major portion of this chapter from where questions actually come. So he have told that okay, actually Huygens was correct. Okay, light is actually traveling in the form of wave. Okay, what was that experiment? We'll discuss in complete detail. As of now, just have the feel of this chapter. Yeah. Okay, this was done, but again after nearly in the 19th, after some years, okay, exactly date I don't remember. After some years, what happened again? Einstein enters into this debate. Okay, Einstein enters and he have explained about photoelectric effect. Photoelectric effect is the modern physics concept that we are going, and in the basic classes I think that all of you are knowing about photons. He have said that light is in the form, is the packet of photons are present. So he have explained that okay, again particle nature was coming into front all of that. Okay, how this photoelectric effect is coming, again it is a debate that okay, it is particle nature now behaving. Okay, so finally and Max Planck was also, and some other scientists were also, a major I'm giving you the overview. Okay, so finally de Broglie enters and he have completed the end of this debate. Until now it is accepted as the de Broglie concept that light is a dual nature. Light is what? A dual nature concept. Dual nature means it is a particle nature also at some time, it is wave nature also at some time. Now what is this sometime? That is what we are going to understand in this complete. Now till complete modern phase we are only understanding the behavior. In geometrical optics we have understood that light is always traveling in the straight path. Now we are going to negate that also. Okay, light is okay, fine, traveling in straight path, but light also bends its path. Okay, light can also bend its path. Okay, but after it is not always like it will be only traveling in the straight line. This is not the case. So that is also what we are going to. So it is a very interesting thing. I've told you about the overview, and we will be understanding about the particle nature as well after some time. Okay, so as of now, let's understand light as a wave nature, and let's begin this chapter without wasting any further time. So be ready with pen and paper. Excited to learn something new? Okay, very nice. Great. See, firstly let's understand what was geometrical optics and what is wave optics. Okay, what is the basic difference? See, we have understood about rectilinear propagation of light. What is rectilinear propagation of light? That light always travels in a straight path, and if light is traveling in a straight path, till now we have understood about the concept of reflection and refraction in complete depth. Dispersion was also there. Okay, these three things, dispersion was from thin prism. Okay, so these three things we have already understood in geometrical optics. But light has some other properties also. Light performs interference also. Light gives you diffraction also. Light gives you polarization also. Now what is these terms? What are these phenomena? Interference के बारे में तो पता होगा. I hope that interference you people would be knowing, because we are coming after studying string wave, sound wave, SHM, that we study a lot of interference. Okay, बहुत बार हमने equation लिखा, and same kind of equations we are going to write here also. I hope that interference is at least clear to all of you. Okay. Now see, rectilinear propagation of light is an assumption provided we neglect the phenomena of bending of light. When we study about rectilinear propagation, we neglect a theory of bending of light, and here we are going to take that in consideration, that light actually bends. Okay, and I'm going to give you explain some very great examples. Today we are only going to watch the practical behavior of light by understanding some examples. Let's question ourselves only that how it is possible, how it is happening. If we have assumed that light is always traveling in a straight line, how this is happening? Okay, so this is what, and that phenomena of bending of light is called as diffraction. That is our second portion topic. Okay, see, if there is a light source here, very beautiful examples are given. Here is a light source, and here I have taken a cross section of wood. Okay, here I have taken a cross section of wood. That is, what do you think? If it is traveling in a straight path, I can say that this complete portion should be in complete dark. Yes or no? And see, this is the highest point, this is the lowest point. If light is traveling in a straight path, what should I say? That okay sir, this complete portion should be completely dark. There shouldn't be a single ray of light should be reaching in this complete section. According to our linear propagation, this should be the concept. See, here it is written, when light is incident on a finely polished disk, it is seen that it is bright spot at the center of the circular shadow formed by the disk. Now what is observed practically, what is observed in this experiment, that a bright spot is coming at the center as well. A bright spot is coming at the center as well. How is it possible? Actually, if light is traveling very straight, that means there is not a single light ray should be reaching in this complete circumference that is drawn here. It is clear now from the diagram. So how that light was coming? Actually, light always bends its path, and that is what rectilinear propagation cannot explain. So here we are going to explain how it is bending. So for that, I told you a science that we are going to understand about Huygens. Okay, a lot of principles of Huygens was also false. Okay, but one concept of wave fronts that he have given, that was of very great use. Till date we can explain all the phenomena of reflection, diffraction, dispersion. All these phenomena can be explained using Huygens. All these phenomena we can explain using Huygens theory. Okay, so it was a very a lot of good uses. Okay, so he have given the wave theory of light. See what he have said. He have given the concept of wavefront. Now what is wavefront? What is wavefront? If you are see, here it is written, when a stone is dropped in still water, ripples are formed on the surface of the water. All the particles on the crest or on the trough, these ripples are in the same phases, and the locus of all such particles is called as wavefront. See, what is the meaning? Yeah, as others. See, what happens when, let's suppose you are having a still water. Okay, now what happens? You just drop a stone into that water. What will happen? A waves will start floating. And when you will be calculating, let's suppose you are throwing here a diagram will be drawn. Perfect. Where is the pen gone? See, let's suppose you have thrown a water. What you will observe, that it will create, let's suppose you have thrown a particle here. It will start like creating this kind of wave, correct? And if you are going at some same distance, let's suppose you are going, because it is in 3D, let's suppose you are going x distance from this center point to all the directions, and when you will be combining all these points, it will create a wavefront. All these points are in the same phase. All these points are in the same phase, and the locus of all these points is actually called as what? Wavefront. The locus of all these points is called as what? Wavefront. See, further, let's suppose you are going to some y distance from this point, from the source from where the wave is generating. Let's suppose you are moving to some y distance. When you are combining all these points that are at some y distance, all these points are again at some same phase. Let's suppose if I am saying that these first points are as phi 1, that means all the points on this circle that have been drawn are at the phase phi 1. Let's suppose you are going some y distance. All the points that are present here are at the, let's suppose if this point is at some phase phi 2, that means I can say this point is also at some phase phi 2. It is very much similar to, if you remember, the concept of in potential, equipotential surface. Actually, equipotential surface, what is the concept? It is exactly cut copy paste. Exactly cut copy paste. If you are very much good understanding of equipotential, what is the concept? That okay, if electric field is going, what will happen? A equipotential surface will be coming, and what will be the direction of equipotential surface? Electric field always be passing perpendicular to the direction of equipotential surface. For a point charge, how we have drawn this equipotential surface? A spherical surface. Here also, for a point source, what will be drawing? A wavefront. It will be a spherical wavefront. Okay, here also you can imagine that, okay, it is having a point. Here we are talking about phases, that all the points on the equal distance, it will having same phases. There we are talking about potential, that all the points on the equipotential surface, all those phases will be same. Here we are going to understand about phases, that all the points will be on the same phase. That is a basic difference that I can say. Okay, so more understanding about it, because it is a very interesting thing. Now I've told you the direction of propagation of light wave is perpendicular to the wavefront. I've told you, just compare from there. If let's suppose electric field is coming towards you, that means what kind of wavefront I will draw? I will draw a perpendicular planar wavefront, that will always be in direction of electric field will be always perpendicular to the equipotential surface, that will be at 90 degree. Here also the direction of propagation of light wave is always perpendicular to the wavefront. Let's suppose if this is a wavefront I have drawn, in the last case only, if I will tell you, see, let's suppose there is a source, there is a light source, light rays are coming like this, light rays are coming in all the directions, and if I have to draw an equipotential surface, I will draw a spherical equipotential surface, and what I will say, that all these angles between the light wave and the equipotential surface are 90 degree. It will always move for now. Different sources of lights are there, and due to that different wavefronts will also draw. Okay, so we are going to understand that completely, that due to different kind of sources, for example, I have told you about point source. For point source, what kind of wavefront you will have? Sorry, wavefront, not equipotential surface. It is much similar but not the same. So what you will be having, let's suppose you are having a point source. Due to point source, what kind of equipotential, sorry, again I'm having equipotential wavefront, what kind of wavefront you will be drawing? See, this is a point source, cover a distance x, that means at x distance from this point source on all the 3D dimensions, all these points will be at the same phase. That means if I am drawing a sphere, all these points are on the same phase. This I will call as what? Wavefront. This I will call as what? Wavefront. Now let's go to some other distance, at some y distance. Again join the locus of all these points are on the same phase. Again it will be a spherical. Again I will say this is the next wavefront, and all these angles that are present here are always what? 90 degree. Okay, always all the rays that are propagating from here, all these angles are how much? 90 degree. Is it clear? So for point source, what kind of wavefront you will have? You will have always spherical wavefront. Same as equipotential surface. For a point charge, what kind of equipotential surface you will have? Spherical. Is it clear? Let's suppose, now let's come to cylindrical source. Let's suppose you are having an infinite, like this kind of source. This is a light source. Okay, tube light, let's suppose. Having a tube light. Okay, this kind of tube light you are having. And now you have to draw the equipotential surface. What you will be doing? If you are imagining in 3D, let's suppose this my hand is a light source, I will go at equal distance, x distance in this direction, x distance in this direction, at all the direction at equal distance. I will observe that all those points are vibrating in the same phase. All those points are in the same phase. And if I am joining the locus of all these points, I will have a cylindrical shape. So I will say a line source, a linear source will always gives you what kind of wavefront? Cylindrical wavefront. Due to why we are studying about wavefronts, it will be feeling very silly, but wavefronts explain all the concepts. Okay, wavefront explain reflection, refraction, all these phenomena. Okay, let's see some other also. Let's suppose your object is at some infinite distance. When object are at infinite distance, that means at very large distance, how rays are appear to come? Always they are coming parallel. In the ray optics also, we have seen that when rays were coming from sunlight, or we have drawn the ray diagrams, so we have assumed that when object is kept in infinity, what kind of rays that are appearing coming towards the surface, it will be parallel. And if you want to draw a wavefront, what kind of wavefront you will have? A planar surface. What kind of wavefront you will have? A planar surface. Planar surface means what? You can use a paper. If a light ray is coming towards you, take a plane surface. Okay, just like an infinite sheet, you can say, because we have the feel of infinite sheet, and all these angles will be how much? Perpendicular. All these angles that are passing through the planar surface will be perpendicular light waves. Okay. So source is at infinity, you will always be drawing a planar wavefront. Correct. So this is what. Now some properties of wavefront, some important properties of wavefront that you have to understand. The direction of propagation of light is always perpendicular to the wavefront. Already we have seen that the direction of propagation of light will always be perpendicular to the wavefront. Second important point, very important, and JEE Mains have asked a very beautiful question regarding this. I will tell you in the question series what was the question. Very interesting question, very interesting. Okay, that question was based on this property. The time taken for by each ray from one wavefront to another wavefront remains same even if the wave is traveling from one medium to the other medium. The time taken between traveling from one wavefront to another wavefront. If I were to tell you that what is the meaning of this, from one wavefront to another wavefront, let's suppose here this is one wavefront, this is the second wavefront, this is the third wavefront. Okay, now if I will tell you the time taken for traveling from this first wavefront to second wavefront and second wavefront to third wavefront, both these times are same. So time travel between two wavefronts will always be same. Okay. Now this is about completely about Huygens theory. Okay, example is given to you for how you can have the feel of Huygens theory. If I will tell you what is happening, there are three scenarios actually. Okay, you have taken a container. Let's understand. If you have taken a container on one side, okay, you have taken a container, and after that what you are getting, you are doing bifurcating them from the center. Let's understand. If we start tapping the water on the surface of water with our hand, the wave or ripples form travels from one end of the other end of the as shown. Here it is the diagram. Basic meaning, let's suppose you are having a container, you are tapping on the one side of the container. That means the wave will be generated and all those waves will be traveling on the other end as well. Very simple. Very practically also that we have seen that if you are disturbing one point, it will the wave disturbance will be traveling to the other side as well. Okay, this is the first case. Second is, now put a partition in the middle of the tank and start tapping again. In this case, waves are only present in the portion of A and B. Now we have bifurcated the portion of the middle. One side is portion A, one side is portion B. And I have bifurcated, that means what, then now what will happen? Now when we have started the disturbance in the portion A, what will happen? Now that wave will not be traveling to the section B. That means it will only remain in section A. Okay, the waves will not be traveling to section B. Clear? Now the third case, now make a hole in the partition and again start tapping water. Now make a small hole. Now make a small hole in the partition that you have given. Now again start tapping water on the section A. This time you will observe a very interesting thing, that the waves are actually traveling to section B. There will be also very little disturbance, but still there will be some disturbance in section B. That means lights are the disturbance have been passed on from there. Correct. And now when you'll observe this, with this, actually what you will see, that small hole that you have created, now it will behave like a source. Now it will behave like a source. Very important point. For example, if I have to draw this here, see, initially it was clear. Now what I have did, I have created a bifurcation here. See, this green color shape is given you a bifurcation, and I will make an hole here. Now again I have created some disturbance here. Now light rays will be what? It will again passing on the other side. And now when I'll observe this on the bigger scenario, this was section A, okay, and section B, light are passing from here. Now obviously waves, whatever the waves are there, they are crossing this hole and then they are coming to the section B. Now when you observe this, this will behave like that. This hole is now a new source and it is generating some wave. And these points are actually defined as secondary wavelets. Okay, the waves that will be generated from here, I will tell you from the next slide. There is a complete description about. See, here there is a light source. Okay, and it is a primary source. What is happening? Light rays are coming out from here. And what we will be doing? Let's understand this complete diagram. You are having a point source. Here. Correct? Now I can say what will be happening. A light rays are coming. What kind of wavefront you will draw from a point source? Spherical wavefront. Very obvious thing. Draw a spherical wavefront. Draw a spherical wavefront. Now, according to Huygens principle, every point on the wavefront that you have drawn will be behaving like a new point source. Okay, this was Huygens principle, that every point that you have drawn on this wavefront will be behaving like a new point source. That means if it is behaving like a new point source, all these points that I have drawn here, more points will be there. I have drawn some very less. So now these points are also started behaving like a point source. If these points are starting behaving like a point source, I can say that they will have their own wavefronts, point source. If what is the wavefront that we have due to point source? Spherical wavefront. That means again they are going to have a spherical wavefront. Here it is not completely drawn because that the direction of propagation is only in the forward direction, but you can draw the complete one. This will be the wavefront for the first point. Let's draw it from another thing. This is the wavefront that we'll have for the second one. This way all these points will have their own wavefronts, correct? And when you are joining the all these wavefronts tangentially, it will give you the direction of your second wavefront. These wavefronts that you have drawn, these small wavefront, these are called as secondary wavelets. Due to these point sources that are coming here, these wavefront that you have drawn is called as secondary wavelets. And when you are joining the all these secondary wavelets tangentially, it will give you the position for your next wavefront. Again, what will happen? Let's understand again. I will say the same thing, that some points on this wavefront will behave like a new point source. If all these points are behaving like a new point source, can I say again they will have their own wavefront? Again they will have their own wavefront, spherical wavefront. I will draw again spherical wavefront, and then what I will do, I will join all these points tangentially, and this green curve that I have given you will give me the position of the second wavefront, next wavefront. And this way light will keep traveling by the concept of wavefronts. This is what Huygens principle. Okay, we have understood by a lot of examples, so I hope that we'll having a little bit of feel. Okay, so this was, you have to remember some important properties of Huygens principle. Okay, direction of wave, if direction intensity of spherical wavelets is not uniform in all the directions. Okay, it is not mandatory that intensity will always be equal, but the intensity is maximum on the forward direction and zero in the backward direction. Actually there is a relation, but it is not of your use. The in forward direction always the intensity of the wave is higher in this forward direction. Like here you will have complete wavelet, I've told you, but the intensity of the wavelet will be higher in the forward direction. It will be lesser in the backward direction. Okay, that's how we always draw the when we are drawing the wavelet wavefront diagram, we always show the forward direction, that where the light is propagating. Okay, because the intensity is higher there. Now let's understand all the phenomena that are occurring. Let's suppose we are having a converging lens. This is what converging lens. And if I will tell you about the ray diagram, this is the ray diagram shown. A parallel rays are coming and it is merging at what point? Focus. Basic ray diagram from geometrical optics. Now let's prove it by the concept of wavefront. What kind of wavefront diagram we can draw for this kind of scenario? See, I will draw with two colors, incident for incident ray different and for refracted or reflected ray different. See, this is the incident ray. What kind of wavefront I can draw? Planar wavefront. What kind of wavefront I can draw? Planar wavefront. These kind of planar wavefronts I can draw, because these are coming from infinite distance, and I've told you when light ray is coming or any kind of ray is coming from infinite distance, it will become parallel. Okay. But after converging, I can say all these points are converging at a point, and that point is going to behave like a image. That point is going to behave like an image, and it is a point source image. For point source, what kind of wavefront I will draw? For point source, I will draw spherical wavefront. So it will be the refracted rays wavefront. You can draw like this kind of wavefronts. This way you will be explaining, correct? If the question is coming to draw the wavefronts, this way you can draw. Let's suppose we will having a not converging, this time I am having a diverging lens. Then what kind of wavefront you will be drawing? Take a green for the firstly, rays are again coming from the infinite distance, and again it is going to converge at focus, but on the same side. It is forming a virtual image. You already know. So for incident ray, again we will have a planar wavefront, no doubt, because light rays are coming parallel to each other. That's why in that case we always used to have planar wavefront. But after diffraction, what is happening? Light will be diffracted like this. Light will be diffracted like this. So in this side, it is not never going to converge at a single point. But if I am extending this ray, this will be the point where I will be getting the converse. So how you will be drawing? Again a point. So again you will have a spherical wavefront, but don't draw the spherical wavefront on the other side. Okay, draw, because light rays are actually not present here. This is just a virtual image. So you have to draw, assuming this as a center. Again you will have a spherical wavefront. So assuming this as a center, draw a wavefront on the other side of the lens like this, assuming that as a center. This kind of wavefront. This is the incident, this is the refracted wavefront. Is it clear? Let's see some other examples as well. This time I have a mirror. This time I have a mirror. Very easy. Again light rays are coming parallel, and after that it is a converging mirror, concave mirror, and after that it always focus from the focus, passing from the focus. So for incident, what kind of wavefront I will have? Again planar surface, plane, because it is coming from infinite distance, and after reflection it is converging at a point, that is focus. Again it is going to behave like a point source, and if it is behaving like a point source, I am going to draw a spherical wavefront. I am going to draw spherical wavefront. This way I have explained you completely that how to draw wavefronts, how you can draw wavefronts. Is it clear? Is it clear that what was Huygens principle and how you can understand Huygens principle? So all these are about Huygens principle, the first portion, basic thing that you have to understand. Now we'll be starting from the major portion, that is interference, from the next class. Okay. Until next time, keep learning, keep growing with Tapasya. Endigo and then Digo Nama Tapasya.